Hey everybody, Trey here. Welcome back to another forecast discussion. We've got another severe weather event on tap for today, part of this very active late April and early May stretch that is on the table here for us. We've had multiple severe weather days over the past couple weeks, and that is going to continue over the next week or two, including today. We've got an enhanced risk out for a large swath of the southern Texas Panhandle down through northwest Texas into basically the southern half of Oklahoma, surrounded by a big slight risk area. We've got a 10% hatched tornado area today. The threat for strong tornadoes is on the table, including places like Oklahoma City, Norman, down toward Lawton, Wichita Falls, Childress, Vernon, areas out there into the southern Texas Panhandle have a chance for tornadoes today, including the threat for strong tornadoes as well. Damaging wind's going to be a threat mainly for the later on today when these storms kind of congeal into a line. And then large hail will be a threat. Perhaps significant hail will be a threat. 30% hatched area here, kind of in those same areas. Places like Wichita Falls, Childress, Vernon, down toward areas south of the Wichita Falls area in Texas, and then including the Oklahoma City metro area down toward Lawton and Ardmore along that I-35 corridor. So all hazards on the table today, perhaps some significant severe hazards today. So let's go ahead and get started here. Pretty complex setup today, but this satellite image is not complex at all. You can just see an absolutely beautiful little area of spin there centered across basically the Four Corners region. That is our trough that is going to be in play for today. It's a little bit higher amplitude than the last system that went through, but still kind of a compact upper trough here that we're dealing with. You can see kind of the southwesterly flow rounding the base of that. We do have a cluster of thunderstorms that is ongoing here across Oklahoma, and that has been the bugaboo in the forecast for the last few days. You can see here on visible satellite where that complex of thunderstorms is. Very strong thunderstorms at this point. Not really severe at this point, but they are some strong thunderstorms elevated, of course, north of the surface warm front, which we'll talk about in a second. Going to move off toward the east today, but the models have been very, very wishy-washy and very, very flip-floppy on the amount of convection that was to be expected here north of the warm front. Some of the models, especially yesterday, had almost the entire state of Oklahoma cluttered with just rain and storms. And now we're seeing that is not going to be the case. We're seeing much less convection here in the target area, at least the eastern portion of the target area, than was expected. So that has large implications on the severe weather threat, the extent of the severe weather threat, and perhaps the degree of the severe weather threat, particularly across Oklahoma here for this afternoon. We'll talk about that more in a second. A couple last notes here with this visible satellite image. You can see the low-level southerly flow here streaming back toward the north beneath that kind of southwesterly flow, rounding the base of that trough. You can see the swirl in the visible satellite imagery even here if I zoom back out. Just an absolutely beautiful trough that we're dealing with here. You can see the swirl here in the clouds. That's that trough that we're talking about, and that is going to be our main player for today. So that low-level southerly flow is already underway here. This is our current radar imagery, just to show you the extent of these thunderstorms here. Again, we were expecting quite a bit of thunderstorms here across this kind of entire region here this morning, and that has turned out to not be the case, at least at this point. 9:30 a.m. Central Daylight Time is the time right now. You can see kind of it's confined to northeast Oklahoma here into southern Kansas, and that's quickly moving off toward the northeast. So the reason that this would be an issue, if this was all cluttered in with convection here, is this would keep that southerly flow from advancing northward. It would keep that warm front farther south and would mitigate severe weather chances farther north. Well, since we're not seeing very widespread convection here, and there's still time for some to fire in here, but it doesn't look like it is firing behind this initial cluster. In this case, because we're not seeing as much convection, that's going to allow that warm front to surge a little bit farther northward into perhaps central Oklahoma, even north central Oklahoma perhaps, but going to have to monitor that throughout the day. But this is a concerning trend, at least for the northern extent of where the strongest severe weather ingredients are going to end up for today. So let's take a look at our surface map now. You can see that kind of broad area of southerly or southeasterly flow here across southern Texas. We've got very, very good surface moisture here, upper 60s to 70s dew points here, south of this kind of line from almost Dallas-Fort Worth southward into the Texas Hill Country and over toward kind of West Texas there, the I-10 corridor. So very good surface moisture down here, and that should make its way northward here as we go throughout the day today, given we're not seeing that much convection up here into Oklahoma. So that warm front is going to continue to move northward as we go throughout the day. We should get some semblance of surface low development out here across eastern New Mexico, West Texas. That's going to, again, strengthen those southerly winds and southeasterly winds and allow the pressure gradient to tighten and bring those that kind of best moisture northward into kind of the Texas Panhandle, Texas South Plains area, all the way into southern Oklahoma. And so good surface moisture here. Let's take a look at our upper level air maps, and this is the 500 millibar map, so about 18,000 feet off the surface, and you can see exactly where our trough is located. Pretty easy to spot here today. This is centered right here over kind of northwest Utah. Some stronger flow rounding the base of that trough. So this is going to move off a little bit to the east as we go throughout the day, and these little shortwaves are kind of allowing these storms to fire right here. If we go down to 700 millibars, probably see a little bit of a kink in the flow, a little bit of a kink here that may be affecting. Kind of hard to tell on this map. A little bit of energy though, definitely allowing these storms to fire here in this kind of warm advection regime. And these little shortwaves aloft may keep those going as we go throughout the morning as they move off to the northeast. But it doesn't look like anything major that will continue the development down here into southern Oklahoma of these elevated storms throughout the morning. So that is a little bit concerning as far as the northward extent of the severe threat. It may allow, again, that warm, moist air mass to continue to surge northward as we go throughout the morning. Let's go down to 850 millibars here. You can see pretty broad low-level jet across, pretty much confined to the southern plains right now. Again, we're not seeing very strong surface low development out here yet across kind of northeast New Mexico into southeast Colorado. So we don't have that much of a mass response yet, but definitely a decent low-level jet, southerly low-level jet throughout the plains, the southern plains here into Oklahoma, 30, 35 knots here across the area. So definitely low-level jet is in place today and should stay in place because we have this trough going to eject into the plains, the southwesterly flow, traversing the Rockies. You get lee cyclogenesis out here. So there should be some semblance of surface low development out here into eastern New Mexico, West Texas. And we should get surface low development to continue throughout the day and allow that low-level jet, that mass response, to kind of continue throughout the day. So let's take a look finally at our surface map here. And you can see we do have some semblance of surface low development already out here. Kind of just this broad area of kind of weak cyclonic rotation here, kind of a couple centers as modeled here by this mesoscale analysis. And again, that should kind of a little bit, I would expect that to kind of consolidate here and strengthen and deepen a little bit as we go throughout the day today. So let's go now to some soundings here. So this is the Norman, Oklahoma sounding for 12Z this morning, 7 a.m. You can see we already have pretty decent you may think we have pretty decent instability in place, but look at the mixed layer cape. It's not showing any mixed layer cape at all, whereas if you look at this sounding, you would see quite a bit of instability here. Well, this is our most unstable parcel. So the most unstable parcel actually has quite a bit of instability to work with, 2,500 joules per kilogram of most unstable cape. And that's going to mean these storms are elevated because we're seeing, number one, you can see the effective inflow layers off the surface, but you can see this very, very steep sort of inversion here. 53 degrees at the surface, warming pretty quickly as you go aloft in the low levels of the atmosphere. So very stout inversion at this point across central Oklahoma. That's why these ongoing storms that we've been talking about are quite elevated, but plenty of energy to keep these storms going throughout the morning, given the large, most unstable cape here at Norman. Let's go down to Dallas-Fort Worth. It gives us a little bit better picture, a little bit farther removed from the storms here. So we do have quite a bit of an inversion here between about 850 and 700 millibars. So part of that elevated mixed layer that's in place, you can see the steep lapse rate plume aloft there. That is our elevated mixed layer. So steep lapse rates aloft here. So we do have the potential for large hail as we go through the day today. And it's going to depend on storm mode as well. If we get discrete storms to last for longer, then we will see a greater threat for significant severe hail with these storms. But Low-level shear should be fairly strong today, so that may inhibit hail growth a little bit. It's kind of that give and take with the lapse rates aloft, thermodynamics aloft, and the wind shear in the low levels that kind of will need to be in balance for large hail to be achieved. And especially with eastward extent, the low-level shear is going to be pretty strong. So that may offset some of these thermodynamics aloft and temper the significant hail threat. But farther out west along the dry line, that should definitely, the significant hail threat will definitely be a risk for today. So again, steep lapse rates aloft, saturated here in the upper levels. That may mean that we're socked in clouds, and as we saw on the visible satellite image, we are. Similar inversion here at Dallas-Fort Worth, so cool air near the surface. Going to have to get some surface heating to help mitigate that inversion, low-level inversion, as well as this elevated mixed layer. So it's going to have to be heated from below or from above, and we're going to have to kind of break that cap from below. The forcing from the trough as well should help lift and cool that cap as we go throughout the day. So we'll expect this cap to erode by mid-afternoon or so, and we should get storm development by then. So the setup for today is kind of interesting. It's kind of going to be a twofold sort of setup. So we're going to have storms out here, potentially as we go throughout the afternoon here across the open warm sector. As that warm front lifts toward the north, that will allow storms to fire in kind of this warm advection regime. And then along the dry line to the west, which you can see is kind of already roughly in place today. You can see eastern New Mexico dew points in the 20s and 30s, whereas to the east of that line, they are in the 50s with, of course, 60s and even low 70s dew points streaming northward. So the dry line should set up somewhere here in the Texas Panhandle as we go throughout the day today. And again, that warm front is going to lift northward. So we're going to kind of have two targets. We're going to have perhaps even three. This triple point, as we've been talking about with kind of these past setups, this triple point is often a favored location for supercell development given the enhanced convergence, enhanced lift along that warm front dry line intersection. Then we'll have kind of the dry line itself down here into West Texas, Southwest Texas as well. And then we have our warm advection stuff and the storms near the warm front here as we go into Oklahoma and North Texas. So kind of a multi-modal severe weather setup for today. And we're going to go through each kind of setup, each area here as we look at the 12Z NAM, the 7 a.m. NAM. So hot off the press here, the NAM is just coming in. So this is our trough at 500 millibars. You can see very well-defined trough flow around the base of that, pretty strong. So that we're going to be right in the exit region here as we go throughout the day today. Nice defluence aloft, spreading out of those wind vectors aloft. That creates that is associated with rising motion. So all this area going to be in the exit region of the trough. So we will get storm development here, no question today in all of these areas. So if we go down to, let's go down to 850 millibars and kind of show you the low-level jet. So the low-level jet in place today, as we saw on our mesoanalysis, may remain somewhat modest as we go throughout the day. This is at 21Z, 4 p.m. Central Daylight Time. But it will start to increase as we go towards sunset and after dark, especially with eastern extent. So with western extent, this is at 0Z, or 7 p.m. So the storms out here maybe dealing with a little bit less wind shear, especially in the low levels here, as it's kind of removed from the main low-level jet axis. You can see low-level jet winds at 850 millibars, about a kilometer above the surface, about 20 knots here out across the southern Texas Panhandle, northwest Texas, into the Texas South Plains. Whereas out to the east here, across central and southern Oklahoma into North Texas, the low-level jet definitely stronger, 30, 35 knots out here. So the wind shear, I would expect, is going to be a little bit stronger, especially in the low levels out here across the eastern portion of that target, that warm advection, warm front regime. But it does kind of increase across the entire area by and just after sunset. So any storms that move into this environment from the west will have will deal with increasing wind shear in the low levels as we go on through the early evening hours tonight. So let's zoom in here, take a look at our surface pattern. So you can see that surface low develops across eastern New Mexico, kind of consolidates out there, doesn't really move a whole lot. And this is the thing here. So the NAM is showing quite a bit of convection this morning across west central Oklahoma, northern Oklahoma as well. And that's going to keep that warm front south. And again, we're not really seeing that as far as the radar goes right now. If you recall, we're not seeing a ton of convection here across this western Oklahoma, south central Oklahoma area. It's just this cluster that's moving off toward the northeast. So this NAM solution may be a little bit of a kind of, we may have to throw it out completely. So we're going to look at multiple models here today. You can see it keeps that warm front pretty far south by 21Z. Keeps the temperatures cool. It does bring it into southern Oklahoma. There's your triple point out here across almost to the Amarillo area, actually, the I-40 corridor. Then our dry line extends back out to the south and southwest. And then our warm sector. Best moisture looks to be kind of pooling along that warm front and just south. But again, the NAM may be way too cool with surface temperatures here because of it staying way too cool and cloudy out here across the warm sector near that warm front throughout much of the day. And I don't use this product a lot, but I like to look at it just to kind of give me a decent depiction of what it's going to be. So this is the precipitation throughout the morning. And so then this is at 15Z, so this would be 10 a.m., right about the time we're doing this video. It shows a huge swath of storms here across south central Oklahoma, extending into northern Oklahoma. And that's just not the case at all. And you can see it just gets really cluttered in here throughout the morning. So we're going to have to watch if this does take place. That's going to shunt the warm front southward toward the Red River area, kind of something like this, rather than it kind of surging up and looking more like that. So we're going to have to watch that. As far as conceptually and kind of what we're seeing, I'm not sure that that's going to be the case. We don't really have a huge sort of well-defined shortwave out here to keep things going. We will have kind of strong warm advection out here. So that's, I think, going to be the only sort of forcing mechanism for these storms is going to be warm advection. So we're going to have to monitor the radar throughout the morning. If this does take place, if this solution does take place, we get a lot of kind of crapvection, as I like to call it, down here in southwest Oklahoma. It's going to, again, shunt that warm front south and kind of mitigate the northward portion of the severe threat and keep it confined to the areas to the south, like the Red River areas just into North Texas and kind of down here into the southern Texas Panhandle. Again, if we don't have this convection fire and we kind of keep it like it is now, kind of clear back out in here, then that's going to allow that warm front to lift northward and allow the severe threat to surge northward as well. So that'll be something to watch for sure. And I think the NAM is just blowing up a lot of convection here. I'm not really buying that here with this model run. So we're going to take this NAM run with a grain of salt here. But let's kind of take some soundings here. You can see how the moisture really surges northward as that surface low consolidates. This is at 7 p.m. Central Daylight Time. We'll go to 4 p.m. You can see this in the southern Texas Panhandle. Moisture is kind of a little bit late to arrive here. The better moisture, at least, stays confined to the south. Don't know if I buy that. We are quite close to the 60s and 70s here. It's not going to take a lot for that to surge northward here into the southern Texas Panhandle. And again, it doesn't take a lot as much out here. You have the cap rock that is higher elevation, allows for a little bit extra lifting mechanism there. So you don't need Mongo dew points to get tornadic supercells out here. So we'll have to watch that for sure. If we can get 60s up onto the cap rock here into the southern Texas Panhandle, that may be a very potent setup to watch. And by 0Z, we actually kind of do get those up into there and stretching out to the east along that warm frontal zone. So let's take some soundings here. We'll take one. I'm going to take one kind of near that triple point, not really well defined here on the NAM. We'll take one down here on the dry line, tight dry line down here. That may be enough to fire storms down here into West Texas. They will be away from the best parameters. Again, the stronger low-level shear is out here across North Texas, southern and central Oklahoma. And then we will take one here just south of the warm front. We'll go at Ardmore here. And again, we're going to take this NAM run with a grain of salt. It does kind of fire way too much convection here on this run. So this is the 12Z NAM. This is for the triple point target, southern Texas Panhandle. 21Z, you can see we're still quite capped here and quite an increase in this kind of dry, warm air aloft here. So the NAM actually has quite a bit of a capping inversion left over across that triple point target. 73 degrees, though, it does seem a little bit too cool. If we look at our surface map now, we're in the 50s. If we get some clearing, which I think is definitely plausible, we should be able to see some clearing and those temperatures warm into the upper 70s at least. So that is a little bit of a concern here. Again, the NAM is often way too cool with these with its surface temperature, so we'll have to watch that. But by 4 p.m., decent looping, decent curvature in the low levels. We have kind of a kink here, a little bit of a weakness in the mid-level winds. That will be something to watch. May favor a more high precipitation mode, a little bit more of a clustered storm mode there. Something we'll have to watch. And you can notice here that the surface winds remain fairly weak, which is interesting. We would expect them to strengthen a little bit given that surface low consolidation out there in eastern New Mexico. But nonetheless, looping hodographs, long hodographs, favorable for large hail, damaging winds, and tornadoes here in that triple point target. This is farther south along the dry line. A lot higher instability out here. Will be, I think, clearer for much more of the day here. Steep lapse rates aloft, so large hail definitely a threat with the steep lapse rates aloft and very large instability, 4,000 joules per kilogram mixed layer cape. But you can see the wind shear out here in the low levels, very, very weak. That may even favor left movers. You can see the storm relative helicity here in the effective inflow layer is negative. And so that would favor left movers, and those are going to be more apt to produce large hail than tornadoes. Large hail is going to be the threat down there for any dryline storms that do develop. That will be the main threat out there. Now, let's take a look at our warm front target. And this is a concerning profile, concerning parameter space here. This almost looks like a southeast kind of setup, where you have often your main forcing out to the west along some sort of Pacific front, cold front, dry line, pseudo dry line. Your main line is out to the west, and you have all these little sort of beans, as we call them, little mini supercells in the warm sector, and often a greater environment for tornadic supercells. And that looks like the case here. You can see we have a perfectly unstable environment here, not much SIN remaining at all by 4 p.m. Central Daylight Time. It's large instability, 25 joules per kilogram of cape here, mixed layer cape. And our hodographs look a lot better as far as low-level shear goes. A lot more turning in the low levels here. Again, that's because our low-level jet axis is out this way. Long hodographs as well, so large hail would be a threat, although the lapse rates aloft are not going to be quite as steep given kind of the cloud cover that may persist throughout the day. But if we get clearing south of this warm front, this is going to be a target to watch for sure. The storms along that warm front are going to have the greatest threat for strong tornadoes. And the warm front, I will note, is kind of oriented almost perfectly for a warm front hog, if you will, that just rides the warm front and produces significant tornadoes. You can see the storm motion here, 234 at 25 knots, so storms will be traveling this way, at least right-moving supercells will. And that is almost parallel, exactly parallel to that warm front. So any storm that can latch onto the warm front is going to have problems today in southern and central Oklahoma into northern Texas. So places even as far south as the Dallas-Fort Worth metro, but more so places like Denton, Gainesville, places like that, and out to the west, Wichita Falls, Vernon, into southern Oklahoma, need to be on alert for the potential for strong tornadoes. You can see a lot of significant tornado archives here. Don't look at this a lot, but this is a pretty concerning sounding, and often one that we see in the southeast with large low-level shear and kind of an open warm sector that is ready for storms to develop, discrete supercells to develop. So that is very concerning out here on the NAM model. Again, we'll have to watch if storms do fire here. This would push the warm front much farther to the north and allow kind of Oklahoma City. You can see on this run, at least at 4 p.m., Oklahoma City is kind of north of the warm front. Storms would be elevated. By 0Z, it gets close. Let's actually take a sounding here. There may be convection ongoing here, so these may be contaminated. But we'll take a sounding here from these places. And you can see, yep, fully unstable here south of the warm sector. Large low-level instability, large low-level shear. So this would be a definite strong tornado sounding. Although the 0 to 1 SRH here, not quite, not super high. I'm not quite sure why that is. But that may be just a model thing. But definitely large looping hodographs here, favorable for tornadoes in a very unstable environment. So this would be definitely the play here as for significant tornadoes. I think the greater threat's going to be out here into central and southern Oklahoma, depending on how far north that warm front goes, even stretching into northern Texas. This warm sector is going to be under the influence of that strong low-level jet throughout the entire day. Even though it's removed from the warm front down here in North Texas, that would be the threat as well. Let's take a look at the WRAP model just to kind of see here. And the WRAP looks a lot different. The overall synoptics are going to be the same, so I'm just going to look at the moisture here, and you can see it really surges northward there, 21Z, and you can see it makes it all the way up into northern Oklahoma. So this is we'll do by 22Z here, and you can see very tight dry line all the way up into the I-40 corridor, warm front kind of up in here somewhere, so the WRAP is very much more aggressive with the moisture return and probably less with the storms here in the morning. Let's get a quick peek at the precipitation product here and see how it handles the precipitation, and you can see not nearly as much as the NAM. It does kind of fire some warm advection storms here, so maybe some showers here that may affect things, but again, just kind of something we're going to have to monitor throughout the day. The models are really bad at predicting this kind of stuff. So let's take a look at the profile out here. We'll go at 22Z again. So it's going to be our dry line target ahead of this dry line bulge out here into northwest Texas plate. This would be right around the Childress area. Then we'll take one out here at Oklahoma City at 5 p.m. here. And then we'll take one at Dallas, North Texas here. So this is our triple point target. You can see the shear is a lot less out to the west, again, because that low-level jet is not nearly as pronounced as it is farther to the east. We have a little bit of low-level shear there. And given decent low-level instability, if that does develop, we would have a tornado threat with those. Significant tornadoes, not quite sure. The mode should be discrete, at least at first. Shear vectors are off the dry line. Large instability out here, though. Steep lapse rates is off, so significant hail will be, I think, the greatest threat here with these dry line and triple point storms. Now, if a storm can fire on that triple point and ride that warm front, then it would have more of a significant tornado threat. So this is going to be central Oklahoma, and you can see the WRAP has much less instability out here across southern and central Oklahoma. And that's, again, the model differences that we're seeing here this morning. But again, the shear profile is a lot stronger here with eastern extent into Oklahoma. Large looping hodographs here would be favorable for tornadic supercells if they can fire, again, instability pending on those. Then into North Texas, not quite as much shear, at least on this run, a little bit greater instability, but kind of the same thing with those warm advection beans ahead of the line. So again, we'll look here, just quickly give you an overview of the storm mode here. You can see very much perpendicular, shear vectors very much perpendicular to the dry line out here, so storms should be quite discrete here, at least for the first several hours of storm initiation. And then often these warm advection storms are quite a bit more discrete just by nature, because the forcing is often less in the warm sector, so you'll just get kind of these pockmarked kind of supercells out here in the warm sector that are discrete. Again, something we'll have to watch is going to be how far that warm front surges, but the profiles out here in the warm sector are a lot more concerning than they are out to the west, at least for a tornado threat. So let's take a look at the HRRR model here. We'll take a look at some cams, kind of see what the different convective allowing models are showing. So this is the 13Z HRRR. So I believe that will be the most recent HRRR that is far enough out for us to look at. Yes, it is. So the HRRR actually has a pretty decent handle on the convection this morning into eastern and northeast Oklahoma. Doesn't have anything firing really back here into south central Oklahoma throughout the day. And this is going to be our warm sector beans, if you will. So just kind of, you can see that sort of pockmarked nature of the storms out here. And this is kind of, again, like your southeast sort of tornado threat. You get the main storms back out here, in this case along the dry line, but you have warm advection storms that may become supercells, tornadic supercells out here in the open warm sector. So actually, let me go down to put the updraft helicity tracks on, just so you can see which storms are kind of rotating there. So you can see we get along that triple point, and the HRRR does fire the hog, if you will, up here into the southern Texas Panhandle. So I would suspect that it does have that warm front getting pretty far north, and yes, it does. It gets up into the southern Texas Panhandle. There's your triple point. Here's your dry line. Here's your warm front. It does include the Oklahoma City metro area, maybe out to the south a little bit here, but it does get into central Oklahoma. This is Cleveland County, so Norman is right in there. So it does have Norman kind of right on that warm front there as we go through the afternoon today. And so let's go ahead and look at some look at this hurricane. So it fires a potent supercell out here in the Texas Panhandle, so places kind of to the east and southeast of the Amarillo area. So going down just south of the I-40 corridor, very potent supercell out here. But you can see these warm sector storms begin to percolate as well, and we get multiple supercells kind of near this triple point along the dry line out down here, and some down here along the dry line here down toward the Fort Stockton area. A little bit of terrain help out here. Again, wind shear out here, low level shear is very, very weak, not nearly as favorable for tornadic supercells. Large hail going to be the threat out here, but potent supercells out here on the triple point, kind of along that warm front there. They would have a tornado threat, especially this northern one that is closer to the warm front, but significant hail is going to be the main threat with these storms, I believe, out here into the Texas Panhandle. Let's take a sounding just out ahead of these storms, and you can see the low-level shear is not super strong. Here's 0 to 1. SRH is a little bit low, but definitely these would be supercells, large instability, steep lapse rates aloft, very large hail in play here with these storms. Tornado threat, at least at this point into the late afternoon hours, may remain a little bit mitigated given the kind of weak 0 to 1 storm relative helicity in these right-moving supercells, but nonetheless would have somewhat of a tornado threat closer to that warm front as well. This is, and you can see now that our warm sector storms are beginning to percolate. This is closer to that warm front, close to Norman right here actually. These storms are supercells here on this model. And let me try to take a sounding here just south of those storms. Yep, and you can see here, large instability here on the HUR, 2,000 joules per kilogram of CAPE, strong low-level shear, strong deep layer shear, closer to that low-level jet axis. These would definitely have a tornado, potentially a significant tornado threat if they can, especially storms closer to the warm front. And those, we get a long track supercell here on this HUR run that plows through the I-40 corridor there, kind of as we go towards sunset, a little after dark. Yep, convectively contaminated there, we'll ignore that. But stuff out to the west congeals into a line pretty quickly, maybe some leading embedded supercells there. But this is concerning for the Oklahoma City, or at least for initially the southern Oklahoma City metro area. And again, northern extent mitigated or modulated by how far that warm front surges northward. Let's go to the ARW here. Has a decent handle on the convection as well. Doesn't fire anything back out to the south, so that will allow the warm front to move farther north. We get supercells to fire here probably mid-afternoon, 3 to 4 p.m. out here along that triple point across the southern Texas Panhandle into northwest Texas, so places along the I-27 corridor, places maybe like Plainview, out to the east toward kind of Memphis, Turkey, Silverton, Paladero Canyon area, and then out eventually toward the Childress area is in play for those storms. You can see the warm front storms, the warm sector storms do percolate out here. A little bit more messy on this particular model here, but we do have some embedded kind of supercells in here. Oops, we do have some embedded supercells in here. A little bit more of a discrete mode out here to the west, interestingly enough. And so kind of a messy warm sector there, and that's going to just kind of have to be something we'll watch. This is the NSSL WRF, so just another cam that we'll look at, and this actually blows up a ton of storms just like the NAM was doing throughout the morning. So if this model comes to fruition, that's going to keep the warm front much farther south and kind of reinforce that warm front kind of near the Red River, Childress, Vernon areas, Wichita Falls area, down into North Texas, and then keep it into southern Oklahoma. So you can see here the warm sector remains cluttered, and not much out here along the dry line. I'm not sure I buy this model. We'll kind of throw this out. Not sure I buy this model, but we do have some supercells, embedded supercells here in the open warm sector where that low-level shear is strongest. Finally, we'll take a look at the FV3 just for kicks. It does firestorms early here, and yeah, this is just a mess. So we'll throw this one out as well. So interesting, we still have some model discrepancies for this setup. It's a very complex setup. That's why this video was a little bit longer, just to kind of give you all the different modulating factors here with the severe threat today. So the main key to remember is we're going to have to watch storms out here into northwest Texas, southern Oklahoma this morning. If we do get renewed storm development out here back to the southwest of this ongoing cluster here in northeast Oklahoma, if we do get storms back out here, these will be elevated, and these are going to modulate the northward extent of the warm front. If we keep it like this, storm-free, that warm front is going to move farther to the north, perhaps including the Oklahoma City metro area, and the severe threat will in turn move north as well. That warm front is going to be the northward bound of that severe threat. If we do get storms to fire down here this morning, continued storms to fire down here this morning and into the early afternoon, then that warm front is going to be shunted south, and the severe threat as well will be shunted south. So that'll be something to watch throughout the morning. But nonetheless, the environment south of that warm front going to be very conducive for significant severe weather. Again, that dry line warm front intersection may be a favored location for supercell development this afternoon. Perhaps places like the southern Texas Panhandle, places like Amarillo, areas to the southeast of there down toward kind of Turkey, Memphis, Silverton, and then places like Childress, Vernon, Wichita Falls. We'll have the threat closer to that dry line in that triple point area for at least initial supercell development out there as we go through the day. Low-level shear out there is much less than it is farther east, so storms out here in the Texas Panhandle into the Texas South Plains will have less of a tornado threat, but still will have a tornado threat, especially closer to that warm front and triple point. But significant hail will be the main threat with those storms, I do believe. Now out here is going to kind of be our secondary target, that warm frontal zone and areas to the south out in the open warm sector. There will be some forcing to get some potentially discrete supercells out here in the open warm sector. The low-level shear is much, much stronger out here in the warm sector, especially with storms that can ride that warm front. Again, that warm front orientation, very favorable for a warm front rider and a potentially long track tornado if you can get a supercell to anchor to it. So I think the better threat for significant tornadoes is going to be out here across central and southern Oklahoma, perhaps including the Oklahoma City and Norman areas, down toward Lawton, Ardmore, the I-35 corridor and I-44 corridors there in southern Oklahoma, into North Texas, Vernon, Wichita Falls, out toward areas closer to the Red River, perhaps extending even as far south as places like Denton and areas just kind of north and northwest of the Dallas-Fort Worth metro area. So that's going to be the main threat out with those storms. Large hail as well, although the large hail threat should be higher with storms out to the west, damaging winds as well. So potent severe weather threat on tap for today. That's all I have for now. Thanks for watching, and we will see you in the next video.